Hey kiddos, I wanted to make you a little video on factoring trinomials and all because even though I know that you have Khan Academy and you all are super smart and you have your textbook and you're utilizing all of your materials, I just wanted to go ahead and do a small video so you guys know that you still have access to me even though I'm home with my sick little guy. Prefacing a couple things. One, you probably hear Baby Shark in the background. Sorry. Two, if I get interrupted by a little one, again, I apologize because I'm sitting at my dining room table. Three, I, again, want to express my sincere apology for being out for so long. I know it's challenging on you. It weighs on me and I feel terrible. I wish I could duplicate myself. My little guy is real sick, but he is, recovering. Slowly but surely he's recovering. So that I'm grateful. All right, now on to factoring trinomials. Okay, so let's hope you can read this. This takes a little getting used to here. There we go. Factoring trinomials. All right, what we need to remember is what is factoring. Factoring is simply like we're undoing something, right? So factors of 20 would be 1 and 20, 2 and 10, 5 and 4. Because really what am I doing when I'm factoring is the answer is kind of like the quotient or the product of two numbers multiplied together. So when I'm looking at a trinomial, what I'm looking at is what two binomials were multiplied together to give me the product, which became my trinomial, okay? All right. A trinomial is something that has three terms. You have a leading coefficient and a constant, right? That'll be at the end. We know all of these things. See if I can come to the side here. All right, oftentimes a trinomial is written in terms of ax squared plus bx plus c. A is my leading coefficient. Oftentimes, like right now, you're doing it with the leading coefficient of 1. C represents our constant. So right away, I want to go ahead and give you your strategy. And then we're going to do some examples, and you can go back and, rewatch this and utilize the strategies. The first thing you want to do is you're going to multiply your A and your C, your leading coefficient and your constant. You multiply those together and you get a product. From there, you're going to list the you're going to list the factors of the product AC. You're going to list out the factors of your answer that you got, right, from multiplying A and C. Once you list those out, then you're going to pick which set of factors, when you add them, give you the B. So I'm going to multiply the A times the C. I'm going to list out the factors of whatever I get as a product for that. And I'm going to pick the set of factors that when I add them will give me my B. Okay? So, caution. Pay attention to signs. Signs are super important, right? Always that's what trips us up the most. We're going to pay attention to our signs. From there, what you do is you simply, in this case, it's x's. So you're going to bring down an x as my first term for each of my binomials here. You just bring an x down for both. The next thing you do is remember those two, the pair of factors that you picked. Well, once you get the pair of factors, all you do is, not that, wrong page. You're going to go ahead and put the two factors in as well. So let's pretend like our two factors were 1 and 2. All right. I know some of you are like, what the what? Don't worry. Let me show you an example. You can come back to this after and rewatch, right? It's just the strategies. I want to list them first. So again, we multiply our leading coefficient and our constant. Take that product, put it off to the side, do the factors of that product. You're going to pick the two factors that when I multiply give me the AC, but when I add give me the B. When I multiply give me the AC, but when I add give me the B. Bada bing, bada boom. Biggest thing, pay attention to signs, okay? All right, so let's take a look at an example here. So our example, first one we're going to do is m squared plus 9m plus 8. m squared plus 9m plus 8. That's what we're doing. M squared plus 9n plus 8. Strategy. First thing, I'm going to multiply the leading coefficient times the constant, or my a times my c. Well, my a in this case is 1. And when your leading coefficient is 1, our lives are so much easier, because when it's not 1, then we have a few more steps. We'll get there, don't worry. But let's start right now. We're just, all of our leading coefficients are going to be 1. So kind of like walk in the park. So 1 times 8 is simply 8. So I'm going to go ahead and write 8 off to the side. Here's my 8. That was step 1. I multiplied. Now I have to list the factors of 8. So my factors of 8 are 1 and 8 and 2 and 4. Those are my factors. Now I could also do -1 and -8, and also -2 and -4, because when I multiply two negatives, again, it gives me this positive 8. And I paid attention, +1 and +8 is a positive 8. So now my next step, all right, sorry, we got cut out there. So my next step, right, once I listed my factors. So right now we still have this m squared plus 9x plus 8. And my factors I have were 1 and 8 and 2 and 4. So what I paid attention to was the fact that this is a positive 8 and this is a positive 9. So I know it's got to be two positive factors that I'm using, because multiplying positives gives me a positive, adding positives gives me a positive. That's what I need. So which of these two factors, when I add together, actually gives me positive 9? Yep, 1 and 8. All right, so now what I'm going to do is I'm going to remember, well, what is factoring a trinomial in the first place? Factoring a trinomial means I'm undoing double distributing. So that means my original problem had two binomials being multiplied by each other. So I'm going to go ahead and list that out. So I'm going to go ahead and put my little skeleton here. I know that this is sort of what it looks like, right? Double distributing. Something here multiplied by something here. Well, since this is m squared, that means it had to have been an m times an m. So I'm going to put down my m and my m right here in the beginning. And again, the leading coefficient's 1, so I don't have to worry about it. So m and m. And the factors I picked were positive 1 and positive 8. So now I'm just going to place them in there because, well, it's what it is. M plus 1 and m plus 8. And that's it. But I'm not stopping there. I'm going to do double distributing to make sure I didn't make an error. I paid attention to all my signs because, right, I want to be correct. So it's easy. I can easily check. So I'm going to go ahead and I'm going to do my double distributing right now, which I want you to do. M times m is m squared. M times 8 is 8m. 1 times m is m. And 1 times 8 is 8. So now I have right here like terms. 8m plus m is, you gotcha, 9x. So my answer ends up being m squared. Or, I wrote an x. Hold on there. Should be an m. Error. m squared plus 9m plus 8. I'm correct. Sigh of relief. I can move on. So now let's go ahead and look at another one, right? Because we know we need practice. The question is going to be n squared plus 3n minus 28. So my next one is n squared plus 3n subtract 28 right here. Now, pay close attention. This is a positive 3n and this is a negative 28. So I already know right away, negative 28, that means that I have to be multiplying a positive and a negative number to get a negative answer. They have to be different signs. The question is, since it's a positive 3n, which one should be the negative and which should be the positive? When I'm multiplying two numbers, I know it has to be negative and a positive. When I'm adding them, I need it to be a positive answer. So that means my larger factor has to be the positive. My smaller factor has to be the negative, right? Because when I add them, I take the sign of the larger, okay? So keeping that in mind, that goes way back to our sign rules, right? Semester 1, like first month of school. So negative 28 factors are negative 1, positive 28, negative 2, positive 14. 3 doesn't go into it. negative 4 and positive 7. And again, I made the 4, hold on here. I made the 4 the negative because it was smaller than the 7. I know that these are factors. Now, I can stop here because I know negative 4 times 7 is negative 28. And negative 4 plus 7 is 3. So, being that it was an n squared, again, I'm going to bring down sets of parentheses. I'm going to bring down my n. N squared means there was an n here and an n over here. So I'm going to put them there. I got an n and an n. And the factors that I picked were negative 4 and 7. So this is going to be n subtract 4 and n plus 7. Do I stop? No. You have to do double distributing again to check your work. Now I know that all of you can do double distributing, and you will see when you do it that you do end up with n squared plus 3n subtract 28. Good. All right, we've got one more we're going to practice. Okay, just so that we got 3 that we practice with different kind of signs. You can go back and watch it, recheck it, remember our strategies. Strategy is everything. Your signs, that's like the hugest part of it. Some of you need to go ahead and rewrite your sign rules again for yourselves that you're going to utilize when you're doing your homework, just because habit makes fluency. Okay? All right. So our next problem is x squared subtract 12x plus 27. X squared plus 12x, or, well, x squared minus 12x plus 27. What do you notice? Different signs. Yep. This time, my c is positive. So when I multiply my a times my c, 1 times 27 is positive 27. But my b is negative 12. So what do my signs have to be when I multiply and it gives me a positive, but when I add it's a negative? When I multiply it's positive 27, but when I add it's a negative answer. Sign rule says negatives, because a negative times a negative is a positive, but a negative plus a negative is still a negative. Yes. So now I'm going to go ahead and I'm going to list my factors of positive 27 using negatives, because I already know that when I add it has to be a negative 12. So I'm going to use negatives right away. Negative 1, negative 27, negative 3, negative 9. I can stop because I know right away negative 3 plus negative 9 gives me, yep, negative 12. Bring down my little, what I call my skeleton here. Since it's a x squared, 1x squared, I know that there's an x in the beginning of each, because x times x is x squared, right? And the factors I picked were negative 3 and negative 9. So I'm just going to then put those back in. So x subtract 3, x subtract 9. This is where I'm at so far. And I'm going to check my work. And again, I'm going to show you the double distributing just to finish it up. So x times x becomes x squared, and then x times 9 becomes negative 9x. See how I distributed the first x into both terms. Now I'm going to multiply the negative 3 into both terms. That's why it's called double distributing. So now negative 3 times x is negative 3x, and negative 3 times negative 9. All right, so I'm multiplying the negative 3 into the x and the negative 9. Negative 3 times negative x is negative 3x. Negative 3 times negative 9 becomes positive 27. So this is where I'm at, okay? Like terms here, don't forget this, right here in the middle. Negative 9 subtract 3 becomes negative 12. So now I have x squared minus 12x plus 27. Looking so good. Correct answer. Round of applause. We've got strategy. We have skill. You guys have the wit. All right, now it's just going to take you practicing. If there are specific questions from this factoring trinomials you're having questions about, send them to me. I'll work it out Okay, I'll try to post these onto Google Classroom and we can have dialogue. I don't want you guys to think that you're without